I kind of thought so. All right, well, welcome to our talk on troubleshooting app compat Windows 7. And in this talk, we'll be going through a couple short phases at the beginning. We're going to address some general overview stuff. We're going to talk about some FAQs, get those out of the way. We're going to spend the rest of our time actually going through and troubleshooting and debugging really honestly broken apps, the sorts of things we look at customers, wherever I can using the actual application, and trying to elucidate the process that we use and the techniques that we have available. So before we begin, how many of you are still using Windows XP? So that's nice and fresh. 9 years really isn't that old. If we think, Windows XP to Windows 7, that's about the same, in kind of the same way that Windows XP was about the same as Windows 3.1. They were 9 years apart, in kind of the same way that Windows 3.1 was about the same as the Commodore 64, also about 9 years apart. We want to help you move forward and regain your platform agility. And that's super important to me, because one of the things I don't want to have happen is this. Here I am, shackled to Windows XP and IE6. So let me spend about $10 million with the bolt cutters cutting off those shackles to walk right up and shackle myself again to Windows 7 and IE8. Well, that's 9 years better. But that's not the position we want to leave you in. We want to leave you being able to be more agile. Now, as we start talking about the fact that it's old, I do want to say that my opinion is not shared by those who put advertisements saying, "Would you drink a glass of 9-year-old milk?" Software's not like milk. It doesn't go bad. It will still work today the way that it was designed. Rather, I think of it like this. When they built structures for the 1904 World's Fair in St. Louis, they built them to last for the duration of the World's Fair. They built them out of plaster and hemp. I like to bring that up because I very seldom get to mention hemp in my talks. But these buildings were designed to last about a year. When you think about software, it's not about how old it is, it's about how long it was designed to last. How long is it designed to last? Typically about as long as it's supported. Maybe a little bit longer to give them some headroom. So when I look at applications like this, I think that perhaps they're being used longer than they were designed to run. This is an actual production application still running on Access 2. When we think about applications also, it's easy for the folks who work on Windows to talk about how awesome Windows itself is. What really matters is your apps. Why do people stay where they are? Their stuff doesn't work. Or they fear their stuff doesn't work. They don't understand that. So that's what we want to get past is, I want to be able to go to a new platform because of what the platform does to me, because of what applications I'm able to run, because of the security features it has, the manageability features it has, all together as one big entity. Incidentally, I took this quote directly from a book by Jeff Richter that was written for Windows 3. And that fact hasn't changed. It's the apps, stupid. And that's what I want to help you with. So let's start off with some of the FAQs, and then we'll get into the nerdy troubleshooting stuff. From an FAQ perspective, one of the most common questions I have is, hey, 64-bit is looking good to me on Windows 7. What's going to break? And the first thing that comes up is 16-bit applications. There is nothing more surprising to me day after day than just how many 16-bit applications there still are in use in the world. Company after company, we keep surfacing them in various corners. I found one company where they were still actively building new stuff in Visual Basic 3 because they bought it at one point with non-professional engineers. They learned it, they started using it, and they never saw the reason to get a new one. I worked with another customer who I had one of the funnier attitudes towards this I've seen so far. He walked in and he had one of the units of his company, one of his divisions, was saying, we have this app, we've been using it at 16-bit, and it's been working great for 17 years. And he just looked right back at them and said, well, you got your money's worth then. So 16-bit is a problem. Identifying those There are tricks to doing that if you have an ACT inventory, but we want to understand that those are not going to ever be made to work if I run 64-bit Windows. What can I do? Run 32-bit Windows, and I can still run them, whether in a virtual machine or whether it's the native OS. 32-bit drivers also potentially a problem, but I haven't really seen much of that in the enterprise. What kind of surprised me was the managed code aspect of things. If I had managed code, that it has this little magic bit to it called any CPU. It's the default compilation mode for the .NET framework. Any CPU means exactly that. You drop me on a 32-bit CPU, I'll magically be a 32-bit program. Drop me on a 64-bit operating system, and I'll magically be a 64-bit process. Well, one of the rules of bitness in a process is that you can't import a 32-bit DLL into a 64-bit process, or vice versa. If I have a .NET application that's importing C++ code, maybe a COM DLL, and that's compiled as native 32-bit, when we run it on 64-bit Windows, we magically promote it to a 64-bit app, and it can no longer import that 32-bit DLL, and that breaks. You can fix that, incidentally. Let me get a command prompt up here. I'll show you a little trick that I used working with one customer. So I'm just going to open up a Windows SDK command prompt. And there's a utility called core flags. Let me actually make this font way bigger than that. Font, we'll do that as 24 point. That should be easy to see. Core flags will allow me to set the 32-bit flag to nail it in as a 32-bit process. So working with one customer, none of their .NET app works because what they were doing is they were controlling an oil drill, which is spraying out sand and water at massive PSIs, and they'd written all that in C code, and a lot of it in assembler, because as soon as one of the sensors goes bad news, they have to shut it down. Well, they didn't write their UI in C and assembler because they're not masochists. So the UI was all written in .NET. So they had UI, all importing these native compiled 32-bit apps. They were all any CPU. We flipped them down to 32-bit CPU. Like magic, they went back to working. So a little trick that comes up along the way, as well as hard-coded paths. So if I have a hard-coded path and I say C:/program files, then I will get C:/program files. If I call the Windows API to get the path, which is accessible via managed code, via scripts, via native Windows applications, then I will get, for a 32-bit process, C:/program files x86. If I always call the APIs, I'm good. If I always have a hard-coded path, I'm good. When I start mixing and matching, then I'm looking in different spots. And then things go south. Beyond that, it works pretty well. I've yet to come across a single example where an application is a 32-bit app, full 32 end-to-end, that under WoW 64 doesn't work. Not one. So it actually tends to work pretty well unless you have one of these exceptional cases and you have the ability to work around them for most of these, except for the 16-bit or the 32-bit drivers, which simply require you to run a 32-bit OS. What about VB6? I have yet to come across an enterprise that doesn't have VB6. Is there anyone here who has no VB6 anywhere? I didn't think so. So this has been a bit of a confusing message. So I wanted to point out, well, I just always use the same search screen. Visual Basic 6, Windows 7, hit number 1 on the good search engine. Oh, there we go, a little snicker. It wasn't very funny, but it was a little funny. We'll tell you all about it. Visual Basic 6, the development environment. The development environment is not supported on Windows 7. Similarly, the development environment is not supported on Windows XP. It's not supported on Windows 2000. It's not supported on Windows 98 because it's not supported anymore. That being said, as far as we know, it mostly works. We just make no promises. If it doesn't, we're not there to help you. But we did have some people look at it to just make sure, because we knew if it positively never ever worked, that was going to be bad news for the enterprise because it was so pervasive. So So the development environment should mostly work. As far as we know, there could be stuff broken. And if there is, unfortunately, we're not helping you. What's more important is the runtime. And the runtime is split up into several different groups, which you can see, but it ships as part of the OS. We list out all of the files that are considered part of Windows 7 and are fully supported as long as Windows 7 is supported. So the runtime, you're good. We have some files that you have to distribute yourself. So you have to include them, and in addition to including them, you have to register them. One of the most common fixes I do for VB6 apps is to modify the installers to not only drop these files, but also register them, calling regserver32 from an elevated context. We finally have a list of unsupported, where you have a compatible update, which is all of the data access stuff, and then the unsupported altogether. Unsupported altogether, as a general rule, means we can't support it because we didn't make it. Typically, these are controls that we licensed from somebody else and therefore don't have the source code for. And you can't really offer support for something you have no source code for, because if someone finds a bug, what are we going to do? We can't release a new one. So it's not because we're like, oh, no one uses that. It's because typically we didn't make that. So there's nothing we can do if you run into a problem. They might work, they might not. If they don't, there's nothing that we can do about it, unfortunately, to help you out. So it's okay to have that for now. I would still be thinking about your long-term strategy. Do you want to keep it forever? Because eventually the runtimes will fall out of support. But for right now, you're okay. You don't need to get off of that. You just want to work about what's my long-term platform strategy going to be. So, final bit of intro is about shims. How many people here have never heard of shims before and it's a whole new concept? 2. How many people kind of get shims but don't think they completely get it all the way to the bone? All right? And how many people feel like they are shim ninjas and really understand exactly how they work? All right, so a few. So most people are in the a couple people are in the I don't know, but most people are the I know a little bit. Might be interesting to know a little bit more. And I do want to make sure that this is accessible to most people while still being sufficiently nerdy for my geeks. So how do shims work? What do they do? What can they fix? And another interesting question that's coming up a lot lately is, what about AppV? So how they work. How they work is based upon a bit of magic in terms of how we implement DLLs in Windows. If you're not familiar with the Windows portable executable file format, I'll just pull open a WinPE file and show you what the import table looks like. When you link to a DLL, this is a statically linked table. So I'm going to use functions from this DLL, the Visual C++ runtime. Now, the DLL can be loaded basically anywhere in memory. It suggests where it would like to load, but it may not get that. So if I look at, let me see if I can find someone who's, I'll use Process Explorer to take a look. Oh, I don't want handles. I want to see DLLs, and I want to include image base and base. Find some rebased ones. Let me see if I can find a naughty person here. Well, that's not interesting. I'm not striking out here trying to find something that needs rebasing. TweetDeck? Really? It usually doesn't take me quite this long. All right, well, what a DLL has a preferred starting address and the address it actually ends up getting. And wow, I'm not finding anything that needed rebasing. That is so unfortunate for me. I'm ruining that demo. Well, the idea is you ask for a base address in the image base. You may not get it. Oh, here I have it. It's just done correctly, too. Oh, no, is that it? Yeah, those are the same. All right. So here's one example of that. It took me a minute to find. Apologies for that. The image said, I'd like my DLL to start here in memory. Then the next one came along and said, I'd like to start here too. Well, only one of them is going to get it. That guy got it. So the other one had to be moved. And that happens rather a lot because most people don't rebase their DLLs to make sure that they have this uniqueness. So the way that we make that work is we have this table that lists all of the functions I'm calling into. When we load the DLL in memory, we just go into this table and say, OK, well, what is the base address you actually got? We'll add the offset. And now, in the code itself, when I call through to find that shim, that API, I just load it at that address. And I just shift the instruction pointer there. So it's a layer of indirection. What do we do with shims? We just overwrite that address with the address of our shim. So the application itself, other than the table in memory, doesn't have to be modified. And that table is modified anyway if the DLL gets rebased. The application thinks it's calling Windows. It doesn't know any better. Windows thinks it's the application calling it if we go on to call it. But all we've done is we've redirected from the import function calling the export function to, hey, we'll just write a new address and bounce through the shim DLL and muck with what we see in between. Does that make sense? Right? It's a much easier technique from a maintenance standpoint than what we used to do, which was code branch directly in Windows, which doesn't really work so well in terms of ongoing maintenance of Windows. Also doesn't work so well if one of your applications is broken because we don't distribute Windows in source code format. So with that basic introduction, what I want to now go through is a series of case studies that talk about some of the compatibility issues that we found, walk through the process that we applied to troubleshooting, talk about the options that we would have to fix them to give you a sense of what can be done. These are intentionally some of the nastier ones. So they are not designed to be representative where every single app compat case is just so nasty, gnarly hard. They're the ones that are interesting, that show you that you can solve even the hardest problems by being systematic. And by being systematic, it's a matter of focusing thinking. I'll give you a quick example. It's a web-based example, but it gives you an example of how I could take a person who didn't really have a strong sense of how to solve the problem, came in and said, my app doesn't work. I don't know why it doesn't work. And a little bit of focused thinking got him to the result. So here was the problem. It was a web page that was calling out to do some image processing. It says it doesn't work on IE8 or on IE9. I said, OK, let's take a look at it. And we'd look at it, and we saw a little counter. On IE6, it was counting all the way up to 100. On IE8, it would go one tick, and it would stop forever. And I said, well, what's the counter doing? He was the developer, so he knew. He said, the counter is a JavaScript that's calling a web service. I said, great. Then there's one of two things that's happening. Your JavaScript's bad or your network's bad. Let's rule out half of them and therefore cut the possibilities from all of the universe to half of the universe, making it go much faster. How do we check the network? On IE, we use Fiddler. We could see one request going through and coming back successfully. The network was operating fine. Therefore, the problem must have been in the script. We've now ruled out half of what could have possibly gone wrong. Now focused on the script, he was able to troubleshoot through it and see that indeed it wasn't stopping, it wasn't crashing, it was proceeding ad infinitum, but it always had the same results values from the web service calls it thought it was making, which was all it took to lead him to the clue, I bet it's caching. And as soon as you think it's caching, it's really simple to sort out if you're right or wrong. Include a web server header to disable the cache, which proved, yes, it was caching. We'd make one request, and then we'd continue looking at the cached request from then on out. How do you solve that? Don't cache it anymore. Put in the header. Cache was immediately invalid, never got saved. always went to the web server, application was fixed. So in this case, it was the fortuitous circumstance where the tool we used to check our theory also happened to be the solution. So I'll go through the big debugging process I think of, and I'll go through the simplified version. Obviously, the number one step is we need to be able to duplicate the bug so someone else can do it. We know the steps it takes to make it happen. We have to be able to describe it. And in the internal troubleshooting team within Windows, we consider that to be a priority 0 interrupt. Is if someone walks in to describe their bug to you for your help, you will stop and you will give them attention. Because sometimes merely the act of describing a bug is enough to solve it. I have had times when I've walked in, pulled open the pen, and just by thinking it through clearly enough to put the pen on the board without writing a single character, gone, okay, I know now, and walked right back out. Taking the time to describe it is worth the investment. The next thing, and this is hard to do, is assume it's your bug. It isn't always. It's sometimes in Windows, but usually it's in the app. Simplify the problem, get it down to the simplest possible repro case, then start to think creatively, figure out if there are any tools that can make it easier. At this point, and only at this point, is it time to start doing any serious debugging. A lot of people jump here and waste a lot of time. I've, at one point, spent a day and a half continuously in a debugger chasing a pipe dream because I hadn't followed the steps. When I'm done, you verify it, and then you document, you learn. I personally blog about it. I keep my notes in OneNote so that I don't forget what I went through to get there. An even simpler process than this is this one. If you have a problem, always find a hypothesis first. There is no tool more valuable than the human brain for solving problems of compatibility. With your hypothesis, then find the tool that most clearly gets to the solution and repeat until the problem is solved. So let's apply this process. So here's, I'll start off picking on our own stuff. Here's a real-world app. You can try this out yourself. Here's the scenario that doesn't work. I'm working with a customer, and they say, we are using Office Communicator 2007 R2. And we're using it for our help desk to connect remotely to our end users to help them out. And the help desk, they're the ones who are going through and doing elevation. They are the ones who are going through and controlling the elevated windows because they're the ones who know what they're doing. When the help desk connects to an end user's computer, any of the windows that are elevated, they cannot control. And that's a problem. So then this gets us into the principle of what would allow them to control that in the first place. What's blocking it is a feature called User Interface Privilege Isolation. UIPI is what prevents you from sending window messages from a lower trusted app to a higher trusted app. That's so that if you get onto a desktop, since Windows don't have security descriptors, if I get onto your desktop running as standard user, or even worse, running as low integrity inside of your browser, that I can't get elevation of privilege by just sending a window message up to some other program running on your desktop with more permission than me and pushing the buttons to have it do the work I'd like for it to do. In this case, we'd like to get around that. And there's a way to get around that by including a UI access element in your application manifest. UI access equals true. And without that, you won't be able to do that. So we looked at that, and I reached out to the Office Communicator team and said, you know, hey, we really need to have UI access, and you don't have it. And I figured out that they don't have it. Here, let's make this font a little bit bigger. There we go. We'll go to Program Files, x86. We'll go into Link, and we will sigcheck/m. Sigcheck is a sysinternals tool that will check the digital signature in any file that you want to. The /m switch will show you the XML manifest inside of that file. So we'll look at sigcheck-m to see if there's an internal manifest at all, and if so, it would show me what that was so I could see, is there a UI access element? I saw no manifest at all. So I said immediately, the problem is there's no manifest, so I could reach out to the team and say, you're blocking this scenario because you have no manifest. The team then responded, we have one. I'm like, all right, that's curious. It seems rather contradictory to both the behavior and to this tool. And I've learned over time that usually in a debate between Mark Russinovich and anyone, Mark is the one who ends up being right. So I'm thinking that they're probably the ones who are wrong. But wasn't going to take it for granted because they had to have some reason for thinking that they were correct. And so I poked around in their binary altogether. They think they have one in there. If they do, it should be in the resources section of their binary. A manifest is a resource of type RT_manifest, which translates to a number of 24. And there is one in here. And if I pop it open, I will see, in delicious hexadecimal format, that it actually does have UI access equals true. So there is some XML in there, and it appears to be asking for it. So they think they've got it right. It looks an awful lot like they got it right, but behaviorally it's not right, and to Mark it's not right. So statistically it's still probably not right. So the question is, what is wrong with it? And the one thing that I noticed, and being observant is one of the biggest helps in my job, is that it was sitting here with this number 2. Which then drove me to my number 1 troubleshooting tool, my web browser. Tell me about RT Manifest, because I don't know everything there is in the world to know about it. And extremely conveniently, hit number 1 brought me to this little bit of definition, which pulls from winuser.h, describing, RT Manifest is 24, so confirming that I'd remembered that correctly, because I could have messed that up, and then showing the resource ID of 1 and 2. I was used to seeing 1. Here I was seeing 2, and I could see, oh, wait, create process and isolation aware, and then it conveniently has a definition that, okay, this is create process is primarily for XEs, and I've got one of those, and isolation aware is used primarily for DLLs, and it turns out that load library reads the resource ID number 2, create process reads resource ID number 1. 2 mail slots, they put it in the wrong one. And as you may have noticed, I'm running against Microsoft Link, which is a currently shipping version that I didn't re-break, because I finally managed to convince them that the bug was there precisely 3 days before the ship date. And it did not block the shipping bar. But Communicator 15 will probably get that right. So now we've got a problem. You've got an app that's broken. A solution that commonly comes up is get a new one, except the newest one you can buy still doesn't get it right. Don't tell the Link guys this. They're here in force. But I wanted to solve my customer scenario. So what can I do? I could, of course, suggest some other tool, but I'd like them to be happy with their tool. What are the rules behind how we read a manifest? If you have an internal manifest and an external manifest, we'll prefer the internal one. If this had had an internal manifest and it was formatted incorrectly, I would have been in trouble. And I would have been in trouble because if I include UI access equals true, there are 2 rules that I furthermore must comply to. Number 1, I have to be digitally signed. Number 2, I have to be installed in a secure location. So if they had a manifest that was in the right mail slot, but it didn't have UI access, I would have been in trouble. Nothing I could do. Because if I modified it, I would invalidate the digital signature. The rule is you must be digital signed, so it goes away. So I had to defer to the fact that, oh, you don't have one, which means create process doesn't know it's sitting in that other slot. What could I do for this customer? I could extract this resource, drop it on the desktop. This is communicator.exe.manifest. And if you install this, I've got TweetDeck up in case there's any questions. Someone thinks it's awesome. Thank you, Wheels847. By extracting this, now I have this communicator.exe.manifest, and I can open this guy up in Notepad and read it. Okay, it all looks formatted correctly. And if I install this side by side, then this extracted one will get processed, and I'm able to dynamically add what communicator didn't put in for me and light up that scenario. It's a hack. Some might call it a dirty hack, but it got the job done without modifying their code. Now, what we next discovered is that all of these side-by-side assembly inclusions, since they'd never actually been run, since the manifest was never read before, don't actually work. So I had to trim them out. And after I trimmed them out, put it side by side, scenario lights up. By thinking creatively about the problem and by understanding the platform. So far, so good? Everyone's so quiet. Thursday is supposed to be the quiet day. That's when you're all supposed to be hungover. Is there a question? Didn't what? The manifest, you don't digitally sign a manifest. It would sit side by side, and it actually works perfectly. So the binary is signed. There's no real way to sign just a text file, which is all that a manifest is. It's just XML. So sitting side by side, it actually worked great. Right? And this customer was perfectly fine running it that way because we weren't modifying the executable. We were just applying the rules which were intended to be applied, but we got it working. And were able to get it working in the scenario that mattered to them. This is also an important lesson about what works and what doesn't work. The definition of compatible is, has no bugs on the platform I want to run that stop me from getting work done. Has no bugs on the platform I want to run, you can't prove. In fact, it was mathematically proven in 1936 by Alan Turing that you will never get there. So all you've got to do is hope you can get to the point where you have none of them that stop you from getting your work done. Most people find no bugs in Link that stops them from getting their work done, but they did. So it was a compatibility bug for them, not necessarily for everyone else. If you don't use that functionality, that software is bug-free, at least as far as we know. Next case study. There's a couple of ones I'm going to kind of tuck into this one because this one was just sort of a really interesting and eye-opening one. Correct file paths. Correct file paths is one of the trickiest shims to use that we have. And the reason why is that it is ruthlessly literal. Ruthlessly. And the reason why we are ruthlessly literal is because that API shims Windows APIs such as create file. Create file, if you ever want to open up Process Monitor and filter on every call to create file, happens rather a lot. So we are heavily optimized for performance in anything that gets in the way of create file. Consequently, it requires a little bit more work on the part of someone who's trying to fix applications. So let's look at an actual broken application written by a company who's exhibiting here today. Hopefully no one's in the room. I'm picking on your stuff, but I'm fixing it. SQL Nav 5. And here's the symptoms that they found. I would try to launch it, and it just flat out wouldn't launch. All right, that's somewhat inconvenient. I'd kind of hope that one would launch. So the question comes up, is anything happening at all? I am not on the screen at all, am I? That was a very boring start of the demo, wasn't it? When in doubt, I had no idea why it was broken, so when in doubt, use procmon. So using Process Monitor, I'll start it up again, SQL Nav, which will have the amazing demo of doing absolutely nothing. See, look at what you missed. But with Process Monitor running, I can go and see what was happening there. If I filter on the process name is SQL Nav, SQL Nav 5.exe, I will see it actually is starting. Here's the process start. We create a bunch of threads. We load a bunch of DLLs. We do some work. And eventually, we do a process exit. So we start and we leave. Something's wrong, so we're going away. So the next question is, well, what the heck went wrong? Now, what was helpful in this case is you don't have to walk too far back to see, oh, I got access denied trying to write to c:/toaddebug.txt. All right? That's something I know how to fix with file system redirection. So what I'll do is I'll start up Compatibility Administrator to apply a shim to it. This is one of the shims that we used in the lab that we had on Tuesday. I'm going to apply the correct file path shim to redirect toaddebug.txt to somewhere else. So we'll do this to SQLNav, some company. And I'm going to apply correct file paths, and I'm going to configure it. Now, just to make sure, I love to copy and paste. I want to redirect from here to user app data toaddebug.txt. So now I'm redirecting to my user directory instead of the root of C, just like we learned in our lab, and that should work great for me. I'm really excited. I'm loving shims. They let me fix apps. That's fantastic. And I'll save this as TechEd and drop this on the desktop and install the database. Go to Launch SQLNav and notice that nothing happens again. Wasn't that supposed to fix it? What's that? User app data is what you supply to correct file paths. And that's actually documented in there. So we actually use a different set of names and resolve them inside of the shim. So let's go back, clear our log, and measure what's happening, and see that once again, while we go further this time, I can still look for the count of my results, and I'm still getting access denied for toaddebug.txt. Now, I thought I just redirected that. Yet, for some reason, it's not being redirected. Now, there are two reasons why that might happen. Reason number one, the call to write that is being executed by a DLL that's sitting in System 32, because out of the box, unless you do something to change it, we exclude the contents of System 32. To see if that is the case, Process Monitor will show me the stack. And I can see SQLNav5 is calling into the shim, so the shim is being applied. It's just not doing anything. So reason number two is I haven't exactly matched the argument that was provided. So I'll show you what I did, and I'll, after that, show you the much easier way, which I helped someone else solve a very similar problem with. What I did was I noticed that we were hitting this when calling create file A. So I opened up a debugger, and I set a breakpoint at kernel 32, bang, create file A. We broke at this point, and then you can look at the argument that's being sent in. Incidentally, my personal opinion, this is a 400-level class. Any 400-level class ought to have assembly language on the screen. If your person presenting does not have assembly language on the screen, mark them down for it. Oh, that was a little funny. So not intended to be a crash course in assembly language, but I'm showing you how I solved it primarily as a means to say you can really solve just about anything with the debugger, number one. And number two, when I next show you how I do it now, which is way easier, you'll be like, oh, I'm doing it the other way. This is what I honestly had to do. I was going through and figuring out, well, what argument is being supplied? For those of you who've never spent any time in a debugger, You're probably scared as hell right now, number one. Number two, I'll show you a neat trick. If you look up the API, it will show you, in lovely C format, what's being passed in. The file name, the desired access, and so forth. When I look at what's being passed in, I can count the number of arguments and dump the contents of that. I know that is a non-Unicode or an ASCII string. I can just dump the contents of that and see the exact argument that was provided to create file A. Correct file paths is ruthlessly literal. I put in C:/. What was being passed in? No C:. Therefore, no match, because it is ruthlessly literal because of performance. So with that in mind, I can copy this guy and modify my shim. Show me the selected ones, click on parameters, and I'm going to remove the C:, save it, right-click install. Now it should match what's actually being passed, and the application will run. But we had that small little speed bump in the middle of I yanked open a debugger and set a breakpoint and was sitting there inspecting random addresses in memory, which most normal people are not that terribly interested in doing. So let me show you what I do now. There's another tool that's way, way better than that if it has anything to do with standard user rights. Lua Bug Light. Aaron Margosis, who's a consultant for Microsoft who works in the federal practice, he's here at TechEd. He's got 2 sessions, both of which, I don't know if they've happened yet or not. One of them is on unintended consequences of security lockdowns, which is an amazing talk. And the other one is a sysinternals primer, which I've heard so many times that I'm kind of a little bit numb to it. But when I first saw it, I kind of liked it. He wrote this tool to help his customers get to standard users. They were uniquely motivated to do that because the White House said they had no choice. This tool you could use to run an app, see what's wrong, and get a report file. So I had a customer, and the customer was rather inconveniently located in Jordan, which is kind of a long ride for me. And to stop by to debug one app was a little bit hard. So here's what I did for the next person that came up with a similar problem with correct file paths. I said, why don't you just run Lua Bug Light and send me the output? So they ran Lua Bug Light and emailed me this file. And I can open the report file and see what someone else collected and look at the issues that happened. And they were getting them all fixed except for this scan0.tif. And when we double-click on this one, so far it looks a lot the same as what we would have had just in Process Monitor. But what we have added by virtue of having used Lua Bug Light is this little extra line. What's the actual parameter that was sent? And they put their dash the wrong way, and it didn't match. Now, Windows then normalized it and opened the file, but correct file paths didn't, because it's ruthlessly literal. So when they applied the shim with the /, app works. That's a little bit easier than the debugger, huh? Let's do a case study to kind of give us a bit of a breather from looking at a bunch of assembly language on the screen. And this was an application that I was troubleshooting for a customer, and they said it's not working correctly on Windows 7. I said, OK, let's take a look. And we took a look, and it's running inside of Citrix. So I'm like, you're in Citrix. It's running exactly the same as Windows 7 as it is on Windows XP because you're just showing pictures of the app running. I don't understand how. Like, well, the problem is on Windows 7, they're peach-colored, and it's very ugly. So we've got to break down the problem now. Hypothesis tool, hypothesis tool. What's our hypothesis? Well, one option is maybe the color depth is different. Maybe we're doing 16 or 32 or 24 on the XP machines, and the way that remote desktop is configured is doing a lower or higher color depth. I don't know. Maybe something's configured differently. So let's sort of look at what the color depth could possibly do for us. And to do that, I opened a full TS window where I specified the color depth at various color depths, and until you got down to like 8-bit, they continued to look peach-colored on the Windows 7 computer. So then I started to think, doesn't look like TS is the problem. What's my next most likely theory? Are you thinking what I'm thinking? Maybe it's a bad monitor. So I plugged in another monitor, and it stopped being peach-colored. So then, just to be thorough, I swapped the monitor cables to make sure it was the monitor that was the problem and not the monitor cable. And then I reported back the problem with this app on Windows 7 is that this computer, which happens to be running Windows 7, has a really junky monitor. You might want to get a new one. Problem solved. That actually happened. But that kind of coincidence is something to be aware of because coincidences matter. I had a web app. I'm not doing a web session. That's on Thursday. But I had a web app that I was working with the customer. I'm there for usually 4 days. And just there to troubleshoot applications, to help them escalate, get some of the roadblocks out of the way. Now, as a general rule of thumb, debugging applications is hard. That's why if you submit a bug report already debugged, it has this amazing tendency to get fixed. Whereas if you send in a bug report that just says it's broken, they have this amazing tendency to start finger pointing. Oh, that must be Microsoft's fault. They must have changed something. Since it's hard, if you have someone coming to your company to debug stuff for free, it is in your best interest to bring as much stuff as you can possibly find to that person. So they did precisely that. I had a user who was testing their applications. It said, this one tested on IE6, it worked. Tested on IE8, it doesn't work. This one doesn't work on IE8. So I took a look at it, and I could see it was just mashing some stuff together. I wasn't getting some results back from various iframe contents. Troubleshot that with Fiddler, saw that it was returning 503 errors. I said, the problem is your server's down. He's like, no, it works on IE6. I said, well, try it now. And he tried it on IE6. And sure enough, it was no longer working in IE6 either, because the problem was this. Test on IE6, step 1, server goes down by coincidence. Step 2, test on IE8, step 3, it looks broken by pure coincidence. So that can happen, so be mindful of that. But I thought that was a kind of funny one. I'm like, the problem is your monitor. On a related issue, here's an interesting one that we come up with when it comes to Visual Basic applications. I'll show you this one. This is a fun one. So they had an application we've opened up, and it looked a lot like this. And the user, quite understandably, said, that's a little hard for me to read. Technically, I can read it, but you're kind of making me work harder than I ought to. Can you do something about that? So the first question I had is, well, if you set it to black, it ought to be black everywhere, and that should be real noticeable. It's the kind of thing that wouldn't ship. So then I started trying to think about, well, okay, how can I dissect this problem? And as thinking about it, I always sort of think about, well, what kind of tools could possibly exist? And at the time, Reflector was still free, and I thought, okay, Reflector can take this sort of pseudocode that gets compiled and give me some visibility. I wonder if anyone ever wrote anything like that for Visual Basic. So I pulled open my favorite debugging tool, my search engine, and found a little tool called VB Reformer, which conveniently has a free version, and not being in sales, I have no budget, so I love free stuff. So I found this little free edition of VB Reformer that will decompile a Visual Basic application, and was able to decompile this app and see, well, what was happening here? And if I look at the graphical user interface code, look at the form, I can see that each of these text boxes is setting its background color to this very strange number. Again, using my favorite debugging utility, I just did a search on that number, and it found nothing. That's fantastic. BB color. And it took me a little bit of time, as you can see, because I'm basically replicating what I did. I don't have this sort of rehearsed and do all that because the real world doesn't come with rehearsals. I'll take the dash off? All right, I'll give that a try. Ah, here we go. And then I can look and find this guy and discover 214. Let's actually translate that into hex, which is going to be much more readable. So we'll go to our programmer calculator. If you haven't found this in Windows 7, you're in for a treat. And translate that to hex and see it's 8000009. 8000009, that is title bar text. The text in the caption, size box, scroll bar, arrow box. Aha! So they haven't set it to black or white or any standard color. They've set it to the color of the title bar text. What color is the title bar text in Windows XP? Anyone? White. Most of the time. What color is the title bar text in Windows 7? Black. Incidentally, title bar text is not always white in Windows XP. This application would have broken as soon as they chose the silver theme, which has black title bar text. So now what can I do about it? It turns out that this is not a problem that I have a shim for. So the solution options we had, we could find the source code and change this to either be the window background color or just plain white if we want it to be guaranteed to be white, just certainly not active title bar text. Recompile it. Or the other solution was we could just hack the binary and just modify all examples of that because I don't have any easy solution to do that. Conveniently, the 3 customers at which I've found this issue, we've yet to find one where we don't have the source code for it, so we've always been able to rebuild it by changing the color. That next got me curious when I got to the 3rd customer that had this problem. Why is it happening so often? If you open up Visual Basic 6 development environment on Windows XP, and you hit the down arrow for pick a different color, what people were doing en masse when the web became hot was all the VB6 folks wanted to feel modern. And the web has what color background? White. So how do you make your VB6 app feel modern? Make it white. So click the drop-down arrow, pick the first white color you see. What's the first white color shown in the drop-down? Active title bar text. So now you're like, all right, so this wasn't just a bunch of idiots who happened to coincide in some kind of strange, conspiracy to make things unreadable, but rather was we've just all coincidentally zeroed in on trying to pick white, picking the first white thing we saw, and not thinking about it. Next issue. People, when they first learn about shims, right, we had a bit of an intro on it. I have a demo application that you can use. If you're not aware of the demo application now ships as part of the Application Compatibility Toolkit. So under the App Compat Toolkit, demo application is called Stock Viewer. I originally wrote Stock Viewer for TechEd 2007 as a way to get people some hands-on experience without waiting for really broken apps. Because really broken apps are significantly messier. If you're going to try learning something, it's much easier to practice on something where it's been simplified than it is to start off doing the really nasty, gnarly stuff. And then once you feel more comfortable, you can do harder and harder problems. So I wrote the app for that, and then it was so useful, everyone said, I want that app. So I said, okay, I'll see about getting it shipped. I tried to get it posted on the Microsoft download site, and there's a little team at Microsoft called the Release Only Quality Team who immediately kicked it back saying, this thing is full of bugs. It even prompts an admin logo at the beginning. To which my response was, that's by design. If it didn't have the bugs, it would be a very terrible shim demo application. They didn't completely get that. It took me 3 years, but now it ships as part of ACT. Takes some time to convince people that bad code can be good in some cases. So people will take this notion of, I want to show shims, and they don't want to show yet another stock viewer application, so they write their own to make it look and behave a little bit different. So they'll have an application that's doing something a little bit strange, and turns out to be something that ought to be fixable using a version lie. And then they try applying a version lie to it. Apply a fix to expense it. And we'll just pretend to be Windows XP Service Pack 3. Save it, right-click, install, and they've written the program. They know that the only thing that's causing it to fail is the fact that it's saying it's not Windows XP. But then they go and run it again, say, OK, now it should be fixed, and they find that once again, it's still not fixed. And then they come to me and they say shims are broken. Tell me why shims are broken. I can't demo this to my customers because they don't actually work. It's at this point that I show them Compatibility Administrator with the super secret undocumented /x command line switch. Launched with that command line switch, you'll be able to see all of the gory details of what's in there. Number one, you see approximately 500 extra shims. We're not hiding them from you if they're useful. Believe me, there's nothing in the world that we at Microsoft won't share with you about application compatibility. Nothing. There are more than enough broken apps to go around, I promise you. In fact, there are too many. If you'd like to take some, happily offer them to you. So we are not trying to hide anything. They're just things like Quicken 2001, designed to fix an issue that's very particular to that application and nothing else. So there's no point in showing that normally because you'll never apply that shim to anything else ever. What it does show that is useful is it will show what is included and what is excluded. By default, we exclude the contents of System32 so that we aren't shimming Windows itself. It's good to know that because if you have a Visual Basic application that requires a shim, you will want to specifically include msvbvm60.dll since it does sit in System32 and that's where most of the things run through. An individual shim can ask to opt out of more, and it turns out that the version lie shims choose to opt out of fixing the .NET framework because the .NET framework itself asks what version of Windows you are so that it can be cross-platform and behaves differently. And it turns out that if we tell the .NET framework that you're a different version of Windows, it behaves differently in ways that can sometimes be bad. And there's no way for us to differentiate between JIT-compiled code generated by the .NET framework and JIT-compiled code generated by you that all looks like JIT-compiled code to the shim. So we exclude it, meaning you can't version lie managed code. You can version lie the rest, but managed code is excluded, and you can see the reason why. Also shows you the tricks that you can see in terms of spotting what's being applied to the fixes. You can also gather some information if you're in unfamiliar territory. So the shims themselves, the documentation is written by me. And I'm a busy guy, so I've gotten through about 30 of them so far, 30, 35. There are about 300, so I'm about a tenth of the way done. So I would understand if that's a bit frustrating. I wish that I had more time to do more. what I've done is I've documented the 35 or so shims that you will use to solve 99% of the problems you'll ever come across. For that remaining 1%, what if you're in unfamiliar territory? What if you wanted to figure out how to use, let me see if I can just find some random shim here. Open directory ACL. If a shim requires a command line to behave correctly, what do I apply to it to get it working? If I search on the name of the shim, in this case open directory ACL, by the way, I don't recommend this in the enterprise because you can open the ACL in a transformation for your installer, which is much more manageable than this one, which just says everyone full control, which might be a bit more permissive than you normally want for an entire directory. You can target it much better than that. But we do it because in commercial software, we can't modify the installers before you get it. Here's the command line. With the /x switch, you can see the command line that other people have used. So /x can be helpful for understanding why something may not be happening. The other thing you can do in terms of understanding what might be happening is to enable shim diagnostics, which I list all the commands on my blog, which will put output that indicates which shims are wiring up. You can watch them in debug view. That's what I normally do in the sysinternals tool, and keep track of it that way. Another case, more of our stuff. I am an equal opportunity debugger. I don't just pick on other people's stuff. SQL Server 2008. So I went up to visit a customer, and the customer was I don't know what the right word for it is, a military customer. So they had built a very aggressive security configuration based on the one we use in the US, which is the Federal Desktop Core configuration. They'd just taken it literally at a point in time, snapshot, and applied it to their own internal security baseline. And they noticed that with this baseline established, they were unable to install SQL Server 2008. Now, hopefully, for those of us who have a financial interest in the success of Microsoft, we've managed to release a product that can install. So presumably, there's something different going on that we'd like to figure out. So we took a look at what was happening by enabling MSI logging. If you're not familiar with that, the easiest way I find to do that is via group policy. What I normally do via group policy is I say spit out absolutely every detail of everything interesting that's ever happened. So under Windows Installer, there's a logging key. I enable it, and I configure it to spit out verbose logs about absolutely everything that's happening. Since SQL 2008 is just a big chain of MSIs, this was going to lead us to the problem. So we enabled logging. We looked at the output of that log. The logs will just go to the temp directory, and they will be prefixed with MSI. So I can find all of my MSI logs that I've run so far. Here they are. I can see details and all the stuff that I've installed. And if they worked, if they failed, if they didn't fail, I can see what was the cause of the failure. Just trace your way backwards, find the failure. You'll have to wade through past all the uninstall stuff, and you'll eventually get to it. And what we saw is that the SQL engine core was the custom action that was failing. Now I know what to debug. So as we started debugging that custom action, we found that it was failing at system.diagnostics.processmanager.openProcess. So we looked at, well, is this thing not impersonating correctly? Because if you are not impersonating as a custom action, then you're running as local system. And local system, sure as heck, ought to be able to get into any other process they want to, because it has the SE debug privilege. And the SE debug privilege is the privilege you need to open another process. So we then took a look and said, all right, well, let's see the privileges that local system has. In order to see that, we could get an elevated instance of Process Monitor, which will allow us to go and pick a service. This one's running as Let's see who this is running as. This is running as local system, and we could see that typically it has the SE debug privilege. When we looked on one of their computers, we noticed it did not have the SE debug privilege, which I thought was awfully strange because that doesn't happen by accident. So then we looked at their group policy configuration, and they've removed the SE debug privilege from everyone, including local systems. So no one was ever going to be able to open another process run by anybody else, which means that you could install absolutely no database software, and all kinds of other software is going to fail also. We then advised them to not apply that security configuration because it's not actually helpful. We add the privilege back in. We're able to install the software. We're going till 11:30, right? Yes? Okay, good. I want to make sure I'm not going over. This thing has been flashing at me for like 6 minutes, but I think it was timed at 60 and not 75 for some reason. All right, so here's another app that we ran. This would kind of give another example. And then I want to, after this one, close it out and then leave it open for question. But this was one that I had a really nasty time getting to work at all. It was a Java application that didn't run most of the time. When it did, it complained about various versions. We were doing some troubleshooting, and we found that if they had enabled next generation Java plugin was enabled, it didn't work. So step number one was to check the configuration and see what is enabled for my Java, what's not enabled for my Java. If I enable this, I won't be able to use this particular application. Then it complained about versions. We had to apply a version lie to iExplore.exe because it was a first run bug. The first time it ran, it checked to see if you were OK, and then it finished laying itself down. The second time, we didn't need to lie to everything. We only needed to lie to java.dll. And I personally am rather hesitant to shim all of iExplore.exe about what version of Windows it's running on. So having to do it once, I was OK with. So we had to build up a process by which we were able to get it installed, finish the installation process, and then move on from there. While we're on the topic of Java, real quick, and then I'll open up the floor to questions. Java is probably the #1 question I'm getting right now. I had a question that came in literally right before I walked over here. So we're trying to run this application, and it appears to be failing. We're running Java 1.5 update 5. Java 1.5, the latest update is update 22, which fell out of support, end of life, in November of 2009. Java is one of the most significant sources of security vulnerabilities going on right now. Let me pull up some MSRC data. Yes. I got to find it first. So here's the chart on exploit attempts against Java and against PDF by way of comparison. I think standardizing on an unsecured version of Java is kind of a bad idea. And standardizing on a version that's now no one cares about, either are no more security updates ever going to come out, is a little bit scary. Right, so Java is one of those conversations I have is how can we get you out of being locked into a particular version of Java with no security updates also. So with that, going the wrong way. A couple more examples, but I'll kind of skip past them. The general caution I would make, and why I talk about this process of hypothesis tool, hypothesis tool, hypothesis tool, is because there's nothing more important than ensuring that you remain focused on the stuff that really matters, as this sign indicates. That's kind of funny. So with that, we have about 5 minutes for your questions. And if you manage to come up with a really great one, then you will win this award. So I invite your questions. Please feel free to step up to the microphone because it is being recorded so people can hear them. Or I'll repeat them if you want me to. I don't mind. Yes, sir.
My question is about calling 32-bit COM objects from 64-bit JavaScript or VB script.
So 32-bit COM objects, you cannot bring them into the process. So if you're running a 64-bit script engine, you won't be able to bring that in. If it's an in-process COM object. If it's an out-of-process COM object, it won't matter. It'll just have its own process, and the process itself is what limits the bitness so that they all run together. Other questions? All right, looks like everyone prefers to leave. That's probably because it's lunchtime. So with that, feel free to come up and ask me questions one-on-one. Oh, there is one question. Oh, go ahead.
Actually, hi. I work for a large enterprise, and as an architect, and while meeting with the desktop engineers, we decided to abandon any shim work.
Okay.
I want everything to be managed, so we're jumping to the AppV and MedV as part of the EA. I like these solutions, but again, most of our issues kind of fall in between Java and IE compatibility, so I don't know how to draw the line here. They're great tools, but I'll have the engineers deal with them, but not as on an enterprise level.
Yeah, it's definitely, so when it comes to IE, we have a whole session on IE tomorrow where we'll be addressing a lot of those because it's what's bubbling up as the #1 issue. Honestly, it's not because it's that much harder. In fact, all of us engineering geeks were thinking, oh, this is an easy problem. We want to do the really nerdy, grungy stuff. So the size of the problem is not as big. The difficulty is not as hard. The problem is no one knows how to do it. Right? So there are a number of things that you can do to make it easier. Another challenge is that there's no in-between. It's either something you can fix via policy, and if you know all the policy tricks, you can get a lot done. But if it falls in between the cracks, you're changing code. Right? As opposed to in the Windows side, where obviously the best solution is fix the app. An intermediate solution is there some kind of duct tape I can apply if I don't require support, or I'm trying to buy my internal team more time, can I apply some duct tape to keep it going?
Yeah, you bet about the pushback from the app teams. I'm dealing with a bigger issue with a suite of apps that the application was locked down on JInitiator, while Oracle themselves are proposing move to 1.6.
They have wiped their hands of JInitiator and will never support it on Windows 7.
I understand the app team locked the apps, and it's very costly to go back and unlock and repackage again. You're looking at, for example, 110K, so they're ready to take that charge. Yeah.
That's a very common challenge is when you lock it in. That's one of the things that I try to advise against is I do understand the logic of locking it in because from a support standpoint, it's way easier to support on a platform that never moves than it is to support on a platform that's changing. So if you just lock it in and say just don't run if you're not something that's moved, to keep your support costs down. But from the perspective of the end customer, that's not terribly realistic because if they don't keep their world moving, then they end up in a position of significantly compromised security, significantly compromised platform abilities, manageability, and so forth, that there's risk in not allowing things to move also. And it's a balancing act, right? So obviously a lot of technology guys are like, oh, just always get the new stuff. The new stuff is always better, which is not always true. But to say, oh, just always keep the old stuff, build it once and keep it forever, is similarly not always true. The right answer is a balance. And helping to tone the balance, or people are willing to accept, it's not reasonable for me to expect that someone will write a platform and support it for 40 years. But it's also very reasonable for me to expect 10. The average lifespan I see for significant investments in applications is around 12. So we're already kind of pushing past the 10 that most platforms will provide support for. That's what Microsoft says is 10. On average, people tend to keep it around 12, and then the last couple, they're kind of duct taping it together going, yeah, hold together, baby, hold together. It's like Scotty down in the engineering room of the enterprise. Keep it together. What's it going to take? All we got to do is keep it moving because we're not quite as agile as you. We're not buying new stuff like the Microsoft guys who are like, hey, there's a new one. Yeah, it's brand new this year. Don't use the 2-year-old one. We got a 1-year-old one. That must be better. It's a balancing act so that you should be able to go when you choose to go, but you shouldn't feel like you have to just because it's new. Somewhere in between is the right answer, I think. And it's hard. It's political, and it's psychological. The other thing that comes up is the developer who's writing the really hardcore, low-level, nerdy app that's doing their own personal, customized software distribution. It's an example I see a lot. That guy loves his job because it's deep and grungy and nerdy, and if he gives that up, he's going to be writing yet another ASP.NET application. He doesn't want that job. The right answer for the organization is stop doing that, because that's expensive and hard and error-prone. But the guy's going to fight it. There's politics, and there's emotions, and psychology, the stuff that nerds like us don't often think about. Thank you, everyone.